All right, so this is lesson 7. This is dividing rational expressions. The way we divide rational numbers is that we multiply by the reciprocal. Or, as my junior high math teacher, Mr. Porter, taught me, we kiss and flip. So, same thing here. What I'm going to do is if I've got 7 over 10, I'm going to multiply by the reciprocal, which is that 14 over 3. And then 14 and 10 can reduce to 7 and 5. I can take a 2 out of both of those things. Now no more common factors. So this is then 49 fifteenths. If I had something like this, I can actually do a bunch of reduction first. Instead of 60 over 50, I can make that 6/5. 9/10 doesn't reduce, but 60 over 50 to 6/5 is much nicer. And then what I do is I multiply by the reciprocal. So 6/5 times 10 over 9, and now I can do some more reduction. I could reduce now, or I could reduce at the end. So I'm going to reduce now, so I can take a 3 out of both of these. 2 left here, 3 left here. I can take a 5 out of both of those, and so this becomes 4/3. Now, the only tricky bit is that when we have rational expressions, we now have a whole bunch of non-permissible values. If I had a over b divided by c over d, where a, b, c, and d are variables, then first, in this first expression, b cannot equal 0. In the second expression, d cannot equal 0. And then the first step is to flip it like this. So when we flip it, when we multiply by the reciprocal, all of a sudden, c is now in the denominator. Now, the d is not in the denominator, but that doesn't get rid of this non-permissible. Again, what happens in rationals stays in rationals. Any non-permissible at any point through the process stays non-permissible. So again, any variable which is in the denominator at any stage in the simplification should be considered non-permissible. So, let's go through a couple. Non-permissible values here first. This is going to be 5/2. And again, if you have trouble just seeing that, you can set that up as 2x minus 5 can't equal 0, and then isolate for x. So that's true first, and then the 0. And now I rewrite it as a multiplication question. And that introduces my new non-permissible, which is that x cannot equal -1, so let's throw that in the list. So same thing here. This one doesn't have a denominator, but I can give it a denominator by making it over 1. So here I have a minus 6 over 3a, a minus 2, times 1 over a plus 3. And then nothing cancels off here, so my non-permissible values are a cannot equal 0, 2, or negative. Okay. If we have something like this where we have more stuff, it's still basically the same thing. Look at your denominators. So x cannot equal 0, 2, or -3, and that's the same for both these. They're both -3, so I don't need to write it twice. Now I invert. X plus 3. Oh, so that's supposed to be an x plus 3. Fix it up. 2x plus 1. And now I have a new limitation, which is again this one. Also can't equal -1. And now I can cancel. Remember, never simplify, never cancel unless you have recorded the non-permissibles. That's like my always nice stop point. I get to canceling, I'm like, oh, wait, I still have non-permissibles I haven't dealt with. But +1 and +1 goes away. plus 3 and x plus 3 goes away. So my finale is x over x minus 2 times 2. I can see it written like this with a division statement in the middle, or I can see it written like this with a division statement in the middle. What I want to do up here first is the first factor everything. So 4 times x plus 3 divided by 3x plus 4, all divided by 3x, x plus 3 over x plus 4 squared. Now what I do is I multiply by the reciprocal, but I need to do all my non-permissibles first. X cannot equal negative, not negative 3. Negative 3 is, well, negative 3 eventually. But negative 4, we already have that listed, so that's it now. But then when we rewrite this as a multiplication statement, 4 times x plus 3 over 3 times x plus 4 times x plus 4 squared over 3x, x plus 3. I've now introduced 2 new non-permissibles. Those were fine, but are now not fine. And now I can simplify. Now that my non-permissibles are done, now I can start looking for common factors. X plus 3, boom. X plus 4, and one of those x plus 4s. So my final answer is 4 times x plus 4 over 9x. And that there is my final answer. All right, find 2 rational expressions whose product is this, but whose non-permissible values don't match. They've done questions like this on the diploma a lot, and I love because you have to think things through. You have to understand the idea. So I see that one of these x's is already, if I just looked at this right off the bat, I would say, okay, x cannot equal 0. So this one makes sense. The 3 doesn't make sense. So what I need to do is I need to include an x minus 3 term. So I could do this, x minus 3 and x minus 3. Now that's okay, but this is really multiplying by 1. You could go like, why would you multiply by that? So I can actually switch it up to go x plus 1 over x minus 3 times x minus 3 over 5x. And I could write it that way, too. Either of those things works. If its quotient is this, well, I can see that the 0 makes sense. I've now got 2 non-permissibles that both have to cancel out. So when they cancel, it has to be an x minus 2, top and bottom, and an x minus 3, top and bottom. Now again, I could do all sorts of crazy stuff here. I want to eventually flip it. So if I wanted to, I could just do this. But I could also flip these things around to make it more interesting. So let's just show you one of these things. I could do x plus 1 times x minus 2 times x minus 3 all over 5x divided by x minus 2, x minus 3 all over 1. Right? That would work. Because now when I divide it, I flip it, those are now in the denominator and then they cancel. One of my favorite things to do is really scramble it up though. And I'm going to do this, where I'm going to put the x minus 2, x minus 3 over the 5x. And then over here I'm going to be divided by, and I'm going to put these things but flipped. So x minus 2, x minus 3 all over x plus 1. That would be fine as well. It doesn't actually matter where I put those things as long as the whole thing comes together. I think that's the assignment there. So that's all the instruction you need. You're ready to start dividing those rational expressions. Hopefully that all makes sense. Come to me with questions and enjoy.